Bismillahirrahmanirrahim. Assalamualaikum to all students. Today we'll be learning topic 6.2, Integration by Substitution. Okay, now I have one example. Okay, the integral of 2 multiply 2x plus 4 power of 5 dx. Okay, now if you still remember the topic 6.1, okay, we learn in topic 6.1, the normal, usually we will expand, okay, the term. This one we have power of 5, okay. Let's say we have 2x power of 4 square, okay. This one is much easier to expand compared to we have the power of 5, okay. So if you remember, first step we expand expression and integrate term by term, okay. However, for this kind of question, you cannot do the same because of it will more it need more time and effort, okay, to find the solution. So here as an alternative, okay, the second one, we simplify the integral by changing the variable. So the easiest way, okay, we change the variable into u, okay, and then we apply the method of integration by substitution. Okay, later I will show to you more detail on how we integrate this kind of problem or question. Okay. Okay, now Madam divide integration by substitution into two different types, okay. The first one is pattern and the second one is no pattern. Okay, so now we discuss the pattern first. Okay, example for this, okay, find the indefinite integrals. Okay, now we have the question A. Okay, the question here, example here is the same like in the one that we discussed just now. Okay, this one. Okay. Now, when the question asks you find the indefinite integrals, means that you have to integrate the given, okay, the function given. So now we have here 2 multiply 2x plus 4 power of 5, okay. Remember, we cannot use the method we learned in 6.1. Okay, for this one, we cannot expand because of the number is too big. It's power of 5, alright. This is power of 5. And then we have to use let, alright. So which one we have to let as u? So we have to take them inside the bracket, okay. Okay, let u equal to 2x plus 4. And then, okay, we differentiate this du over dx, okay, du over dx equal to, differentiate 2x we get 2, differentiate 4 we get 0, okay, no need to write. And now you have to separate du, okay, stay at the left side and dx at the right side. So meaning that 2 multiplied by dx. Okay, now we have du equal to dx, right? So to simplify the function here, we have, okay, as you can see, okay, we have here 2, okay, here we have 2 and then here we also have 2, right? And then dx we also here as dx, meaning that we have, okay, why we call this one as pattern, okay, falls under pattern type. Okay, so because of we already, okay, after the differentiate, we can see that the term that we have here is similar in the given function, okay. So now we can just replace 2 dx as du. Okay, we have to form a new integration, okay, the integration, okay, this is the new integration in terms of u, alright. So next, okay, integral of, okay, 2 dx, we just leave it, right? Okay, just we focus this part first. Okay, now inside the bracket we have 2x plus 4. Now we replace this one with u, meaning that u power of 5, okay. And how about 2 dx? Okay, 2 dx, we replace it as du, okay, meaning that u power of 5 multiply du. Or in simple way, okay, another method, I also teach my student to cancel out, meaning that we already have here 2 and we also have here dx, okay. Okay, the term left here, meaning that this one we replace it as u and then power of 5, and then the term that we cancel just now, we replace it as du, okay. So now we can say that the term is much more simple compared to the previous one we have, this one, alright. Now for this one, integrate this, okay, the power we have to add 1, we get 6, 2 power of 6 divided by 6 plus c, okay. Okay, but this one, our final answer must be in terms of x. So you have to replace u with this one, 2x plus 4. Okay, so 2x plus 4 power of 6 divided by 6 plus c. Okay, this is our final answer. Alright, so I hope you understand. This is the step where we apply the integration by substitution. Okay, when we have to use this one, when we have the power, okay, the power of 5, the power of, okay, normally more than 3, okay, we use this method. Okay, I hope you understand. Okay, this is example B. Okay, so all terms inside the bracket as u. Okay, so now you can see how can madam solve this question. Okay, first we let u equal to x squared plus 3, and then we differentiate the expression, we get 2x, right? When we differentiate x squared, we get 2x plus 0. And then we can see that, okay, this one, okay, 2x we already have in the question, right? So now, okay, we have to make sure that, okay, du is equal to dx, meaning that this one part, okay, must be all in, okay, in terms of x. Okay, so when we get this one, okay, 2x dx, so we already know that this term already we have it in the question, so that's why we call it as pattern. So now we can just simply, okay, cross this one, and then we construct the new integration where now we use u, okay, in terms of u. So the integration of, okay, this one 2x dx, now we replace as du, right? So all term inside the bracket, so now we have here u equal to x squared plus 3. Okay, u equal to 2x plus 3. Now we put no bracket, okay, this one as u, so u power of 4. Okay, this one you already cancel, and then we replace it with du. Okay, just simply integrate this one, u power 4, u power 5 over 5 plus c. Okay, now we replacing u with this one, x squared plus 3 power 5 divided by 5 plus c. Okay, this is the solution. Alright, simple, right? Okay, this is question C. Okay, the integral of 3, okay, multiply square root of 3x plus 1 dx. So now this one is a very complicated, okay, when we want to change this one into 3x plus 1 power of half. Okay, this is so complicated when we have to expand this, so we now apply integration by substitution. So now to apply this, okay, you have to let u equal to 3x plus 1. Normally we choose term inside the square root or inside the bracket. Okay, so let u equal to 3x plus 1, and then we differentiate this, we get du over dx equal to, differentiate 3x we get 3, differentiate 1 you get 0, right? Okay, and then okay, du equal to 3 dx, meaning that we now separating u and then x with x. Why we have, okay, why madam choose 3 dx? Because of I can see that I have the same term of 3 dx in the question. Okay, this is why we call it as pattern. We can see, okay, after differentiation we can see that the same term in the question. Okay, so what madam did, what madam do is madam cancel out this one. So we know that 3 dx is now equal to du. Okay, so now we solve this. We got, okay, the integral of, okay, inside the square root, okay, we have here, we now replacing 3x plus 1 with u, and now 3 dx we already cancel, and then we replace it with du. Okay, all must be in terms of u. So when we integrate this, okay, change into this one, u power of half du. Okay, when we integrate this one, we get 1 plus 2, 1 over 2 plus 1, we get 3 over 2, right? Divide by 3 over 2 plus c. Okay, don't forget about this fraction. When we divide the fraction, this one you have to remember that, okay, u multiply with 2 multiplied with u 3 power of 2 divided by 3 plus c. Now we're replacing u with 3x plus 1 power of 3 over 2 divided by 3 plus c. Okay, so this is the answer. Okay, this is example D, where we have here the integral of x squared multiply x cubed plus 1 power of 3 over 2. Okay, so now which part that we have to choose as u? So this one, okay, normally we choose inside the bracket. So to solve this, let u equal to x cubed plus 1. Okay, one more thing, how do we know that we have to choose x cubed? Because of now, when we choose this one, you have to try to solve it in your mind. Okay, let's say when we differentiate x cubed, what will I get? So when we differentiate this, we get x squared, right? 3x squared, where we see that x squared we already have here. So now is this one, the hint that we have, okay, to guide us to choose which one that we have to change it as u. Okay, so now u equal to x cubed plus 1. So du over dx equal to 3x squared. Okay, now we can see here in the question we have x squared and dx. Okay, no 3. Okay, the question doesn't consist 3. So what you have to do, you have to bring it bring 3 to the left hand side. Okay, so now we get du over 3 equal to x squared dx, where this one same like in the question. Okay, so I hope you're clear. So the things that not necessary to be there, so you have to remove to the left side. Okay, to solve this, okay, remember we already cancel. Okay, now we're replacing x squared dx. Okay, we cancel out this one with du over 3, right? So now when we have du over 3, okay, so now we're replacing this with u power of 3 over 2 divided by du over 3. Okay, because of now the term that we cancel, we replace it with du over 3. Okay, now we know that when we have constant, we can put it outside of the sign of integral, of the integral. Okay, the integration. So now we get u power of 3 over 2 du. Okay, 1 over 3. Okay, integrate u power of 3 over 2, we get here plus 1, we get 5 over 2, right? Divide by 5 over 2 plus c. Okay, when we have here 5 over 2, so we can multiply 2 with u, divide by 5 plus c. Okay, so you can simply multiply, so we get here 2u 4 over 2 divided by 15 plus c. So the final answer is, okay, replacing u with x cubed plus 1, okay, power of 5 over 2 divided by 15 plus c. Okay, this is the final answer. Alright, so I hope you understand this one. Okay, now we have here example E. Okay, the integration of e power of negative 3x dx. So now we can see that we doesn't have a bracket, or we doesn't have any square root. Okay, but we have the exponent of e power of negative 3x. Okay, remember we cannot solve this one by using okay, for your information, in the integration we doesn't have any exponential rule. Okay, what we have to apply integration by substitution to solve the exponential function, where this one we get we let u equal to negative 3x. Okay, so differentiate this, du over dx, we get negative 3. Okay, and du, okay, we cannot we didn't see 3, right, in the question. So now we bring 3 to the left side, so we get here du over negative 3 equal to dx. Okay, so now we replace dx now with du over negative 3. So now the new integration in terms of u, we have here e power of u, because of we let u equal to negative 3x, and then dx is equal to du over negative 3. Okay, remember what? Okay, how can I solve number 3? So I put it outside of the integration form. Okay, out of the integral this one that we have. So now we solve. Okay, when we integrate e power of u, we will get the same thing, right? Plus c. So negative 1 over 3 e power, okay, replacing u with negative 3x plus c. Okay, this is the solution. Okay, so I hope you understand this. Okay, this is example F. Okay, now which one you have to choose as u? Okay, this one, is it x or 3x squared plus 1? Okay, the answer is you have to choose this one. Okay, all of the terms. Okay, meaning that let u equal to 3x squared plus 1. So du over dx equal to 6x. Okay, now we cannot see x in the question, right? So we bring it to the left side. So we get here x dx. So I can see here we have now x dx and also x. Alright. Okay, now we change all this one, like the integration into new integration in terms of u. Okay, integration symbol, and then we now have x already. We cancel this one, it will be 1 over, okay, this one we let u, right? Okay, over u multiply. Okay, now in terms of u we have to take this. Okay, du over 6 divide by multiply by d. Why multiply? Because of now we have 1 over u multiply dx, right? So dx we're replacing it with du over 6. Okay, simplify this. Okay, you can bring constant outside. So we get here 1 over 6. Okay, 1 over u du. Okay, we know that when we integrate 1 over u, okay, this one falls under power rule exception. Okay, so when we integrate this, we get ln u plus c. Now we change ln, okay, u in terms of x, we get here 3x squared plus 1 plus c. Okay, so this is the solution for f. Alright, where we apply log function. Okay, now we have example G. Okay, so I give you more examples. I hope you understand. Okay, now we have ln x squared divided by 2x dx. So which one we have to take as u? Okay, so the answer is this one. Okay, ln x, because of when I differentiate ln x, okay, the answer is 1 over x. Okay, how do we know? Okay, let's try. Okay, let u equal to ln x. Okay, differentiate this one, du over dx. We know that basically, okay, this one ln x is equal to log x base e, right? So we apply the concept of derivative of log function. So we get here x. Okay, we bring it here x, and then ln e, differentiate x, we get 1. So the answer is, okay, ln e is equal to 1 over x. Okay, so we know that every time when you differentiate, okay, when you differentiate dy over dy, okay, let's say y equal to ln x, when we differentiate dy over dx, so we get here 1 over x. So you have to remember this one. Okay, okay, so that every time you see ln x, you differentiate, you get 1 over x. So now, okay, the answer is du over dx equal to 1 over x. Okay, so now we can see that we have here dx, okay, du equal to dx. Okay, if you are confused, this one you can put like this. Okay, 1 over x multiply dx, where I can see this term in the question, where I have here dx and I have here 1. Okay, you can just imagine here we have 1, right? We have 1 here, 1 over x. Okay, 1 over x. Okay, so now we can just simply cancel out this term. Okay, so now we have over 2, right? So we change all must in terms of u. Okay, don't forget to do this one. Okay, the symbol of integration. Okay, now ln x is equal to u, right? Okay, u square. Okay, don't forget about 2. Okay, 2 is still there. Okay, even though we didn't have, okay, we didn't have here. U square over 2. And then, okay, we cancel x, the x, and now we change this one into u, du. Now we integrate this one. When we integrate u power of 3 divided by 3 multiplied by 2, we get 6. That's c. Now, okay, replacing u with ln x, right? Power of 3 over 6 plus c. Okay, so this is the answer. I hope you understand this part. Okay. Okay, where I get, okay, u now is equal to, okay, so I'll just delete, okay, ln x. Okay, u we replacing with ln x. Cube, we still have cube, divided by 6 plus c. Okay. The last example, okay, where it involves the exponential function. Okay, now we have the integral of 2 power of x minus 1 divided by 2 power of x plus 3 power of 4. So remember, when we have here bracket, so normally we choose all terms, okay, the terms inside the bracket to be u. Okay, let u equal to 2 power of x plus 3. Okay, differentiate this. Okay, remember why we have to choose this. We can see here we also have 2x, right? Here. Okay. Okay, du over dx equal to, okay, differentiate 2x. This one you have to apply exponential function, okay, exponential rule. So we get here 2x ln 2. Differentiate x, we get 1, right? Okay, no need to write. Plus 0. Okay, so now we already have 2 power of x in the question. So now for the ln u, normally we put it at the left hand side, equal to 2 power of x dx. Okay, so this is the function that already differentiate. Now we want to change it into, okay, the new integration into in terms of u. So this one, okay, we know that for this one, 2x multiply with 2 power of negative 1. Okay, this one equal to 2 power of x. Okay, when we multiply the same base, the power we add, right? So plus negative 1. So meaning that this one we will get the same thing, okay, like in the question. Okay, so divide by 2 power of x plus 3 power of 4 dx. For negative 1, we can just bring it down. So there will be 2 multiply 2x plus 3 power of 4 dx. Okay. Okay, this is the new integration when we simplify this one. Okay, so now what we can see here, we have, okay, dx and dx. We have 2 power of x. Now we already have 2 power of x. Okay, we can just replace this one, okay, with du over ln 2. Okay, now we try to change the pattern. Okay, we cancel this one. Okay, later we replace with du over ln 2. Okay, 1 over 2. Okay, all terms inside the bracket, like, okay, we replace it as u power of 4 multiply, okay, when we cancel 2 power of x dx, we replace it with this one, du over ln 2 multiply du over ln 2. Okay, so simplify this, we get 1 multiply du, so we get 1 over 2u power of 4 multiply ln 2, so 2 ln 2 u power of 4 du. Okay, so now we can see that we have constant 2 ln 2, right? So we can just put it outside, 2 ln 2. Inside the integral, we have 1 over u power of 4 du. Okay, okay, again, okay, this is the constant, so you have to take it out. Okay, so only left 1 over u power 4. Okay, to solve this, you have to bring u, okay, bring it up, so there will be negative power 4 du. Now you can simply integrate this one. There will be u power of negative 3 over negative 3 plus c. Okay, simplify this. We get 1, no sorry, u power of negative 3 over negative, okay, negative 3 multiplied by 2, so we get here negative 6 ln 2 plus c. Okay, we can just bring it down for this one. There will be negative 6 ln 2 u, okay, multiply u power 4 plus c. Okay, now okay, now u is equal to 2 power of x plus 3. Plus c. Okay, so this is the solution for example, the last example. Okay, example H. So the answer is negative 1 over 6 ln 2 multiply 2 power of x plus 3 power of, sorry, this is not 4, this is 3, power of 3 plus c. Okay, so I hope you understand. Okay, this is the second part in the integration by substitution, where previous example we learn pattern integrals. Okay, the second part is no pattern. Okay, the example says find the indefinite integrals. Okay, for example A, the integral of x multiply x plus 1 power 4 dx. Okay, after this we will see why we call it as no pattern. Okay, so now we apply the same step like we do in the previous example. So we let u equal to x plus 1, and then we differentiate this one. Differentiate x, we get 1. Differentiate 1, we get 0. So du equal to dx. Okay, now we already have dx, but the difference is, okay, now we have, okay, suddenly we have x here. Okay, how we can solve this? We have to, this one, okay, make this one u as a subject, right? Make x as a subject. Okay, so there will be, okay, now u equal to x plus 1. Okay, x plus 1, okay, we change okay, the position, x plus 1 equal to u. Okay, therefore x equal to u minus 1. So now the question that we have, x here, you have to replace it with u minus 1. Okay, in the new integration. Okay, when we have integration in terms of u. So now we have integration. Okay, x, we have to replace it with u minus 1. And then now, okay, the term that I already shaded in yellow color, this one you have to change into u power of 4. Now, okay, dx, we replace it with du. Okay, now you have to expand one by one. Okay, now we have the new integration in terms of u. Okay, to solve this, you have to expand one by one. Okay, now we get u power of 5 minus u power of 4 du. So now we can integrate one by one. Differentiate u power of 5, you get u power of 6 over 6 minus u power of 5 over 5 plus c. Therefore, the final answer, replacing u with we have here x plus 1. Okay, here u is equal to x plus 1, right? Okay, replace x plus 1 power of 6 over 6 plus, minus x plus 1 power 5 over 5 plus c. Okay, so this is the final answer. Okay, I hope you understand this one, the step. Okay, so this is the last example for the pattern, okay, type of integration. Okay, now we have to solve this one. We have the integral of x power 5 divided by x squared plus 3 dx. Now we have to let u equal to x squared plus 3. We choose all terms inside the bracket, and then we differentiate we get here 2x. Okay, now we can see that here we have x power 5 and now we have x. Okay, 2, we have to bring it to the left side, so it be, okay, division, du divide by 2 go to x dx. Okay, so now I can see here in the question I have x dx, where this one is equal to x power 4 multiplied x. Okay, why x power 4 multiplied by x? Okay, to get x power 5 here, divide by x square plus 3 dx. So now class, okay, when we see x dx, we can just cancel x dx. Okay, the 1x, and then the term that we have here, okay, x power 4. Okay, this is why we call it as no pattern, because of doesn't exist, okay, in the term that we already differentiate. Okay, we already cancelled it. Now x dx is replacing with du over 2. Okay, so now how can we change x power 4 in terms of u? Okay, you have to look it here. Okay, when we have u equal to x square plus 3, okay, bring x to the left side, we just change the position. So x square equal to u minus 3, right? Okay, now we want x power 4. When x power 4, you have to just square the term. Because of now we have square, to get power 4, we have to square the function. Okay, this is, okay, x4 equal to u minus 3 square. So the new integration in terms of u we have here. Okay, for this one, x power 4, we replace it u minus 3 square. Okay, x dx we already, okay, now we replace it with du over 2. Okay, when we cancel, we replace it du over 2. Divide by, okay, terms inside the bracket, so now we let as u. Okay, okay, now we simplify one by one. Okay, this one, even though we see we have the power of 2, we still can expand it, okay, by using meaning that we can, because of the power is only 2, we can expand it one by one in the simple way. Okay, u square minus 6x plus 9 divided by u du over 2. Okay, we multiply. Okay, I hope you understand. Du we multiply with u, we get 2u. Right, so now, okay, remember what we learned in 6.1, so we just separate this. U square divided by 2u minus 6, this is not x, okay, this is u. Okay, 6u divided by 2u plus 9 divided by 2u du. Okay, when we have the same denominator, so we just separate them into 3 parts. Okay, 3 terms. Okay, we can just cancel out, so u over 2, 6 over 2. Okay, this one cannot simplify. So this one, okay, you have to integrate u over 2 minus 6. Okay, 6 divided by 2, so we get now 3, right? Plus 9 over 2u u. Okay, integrate this u, we get here u square. Okay, you have to bring it down, so 2 multiply 2, we get 4. Divide, okay, integrate 3, we get 3u plus integrate 9 over 2u. So when we have here 1 over u, we get ln u plus c. Okay, so now replacing u with, okay, now u is equal to x square plus 3. Okay, x square plus 3, x square plus 3 square divided by 4 minus 3 multiply 3x square plus 3 plus 9 over 2 ln x square plus 3 plus c. Okay, so this is the solution. Okay, where we apply integration by substitution, where this is no pattern. Okay, why no pattern? Because of after the differentiation, we doesn't have the term now. Okay, for example, now we have doesn't, okay, this one. Okay, you have to be careful, okay, because of x power 4, we cannot solve it after we differentiate. okay, the term that we let as u just now. So we have to make u as a subject, and then we replace it into the new integration form, right? So I hope you understand.